In this lesson, we're going to learn about rationalising the denominator. To do this, there's a couple of things you need to remember. First of all, a surd is an irrational number. So anytime you have something like root 3 or root 2, it's an irrational number. So by rationalising the denominator, we're getting rid of any surds that might be in the denominator. Have a think about what happens when you multiply a surd by itself. So if I do root 3 times root 3, I get root 9, which of course is 3. So any time you square a surd, the square root and the square effectively cancel one another out, and we get the number that was just under the surd in the first place. Root 2 squared is just 2, etc. So keep that in mind. The other thing you need to remember, and I know you all know this, is if you multiply anything by 1, it doesn't change the value, of course. And in any fraction where the numerator and the denominator are the same, equals 1. So if I had 4 over 4, of course that equals 1. If I had root 2 over root 2, that equals 1. If I have root 5 over root 5, that equals 1. All of these things keep in mind as we go through the lesson. So if I ask you to rationalise the denominator here, you'll notice that each one of these fractions in the denominator there is a surd. So I have an irrational number in the bottom, which I don't want. Mathematical convention asks us to always express numbers with a rational denominator. So if I have 2 over root 3, irrational number in the bottom, what I'm going to do is multiply this fraction by 1. If I multiply this times 1, my answer is still going to be the same value. It's still going to be 2 root 3. Instead of multiplying it by 1 written in this form, though, I'm going to write my 1 as root 3 over root 3. I know that root 3 over root 3 is 1, so all I've done is multiply it by 1. So I'm not changing the value. But what I am doing is changing the way that this then is written. Multiplying fractions, I just multiply my numerators, multiply denominators. 2 times root 3 is 2 root 3. Root 3 by root 3 we know is 3. So this 2 root 3 expressed with a rational denominator is 2 root 3 over 3. If you don't believe me that I haven't changed the value, if you key this into the calculator and get a decimal approximation, you'll find that it's exactly the same value. All I've done is multiply it by 1. Let's have a go at part B. So I have 3 root 2 over root 5. I don't want root 5 in the denominator, so I'm going to multiply it by root 5 over root 5, which, as you know, is 1. But what's going to happen is I'm going to end up with root 5 times root 5, which is just 5 in the bottom. Then I'm going to end up with 3 root 10 in the numerator. Rational denominator. Notice that each time I'm just choosing whatever surd I have in the bottom. That's what I use to make up my 1 here. This one here. 2 root 6 over 5 root 2. Now I could multiply it by 5 root 2 over 5 root 2, but that's going to make the numbers too big. And then you'll have to look at cancelling down. So still just pick out this surd component. Pick out the irrational component, root 2 over root 2. So I'm going to end up with 2 root 12 over 5 by 2, which is 10. Now that's not wrong, but it's not in simplest form. A couple of things we need to do. First of all, I can cancel my 2 and my 10 down. So I'm going to end up with root 12 over 5. But root 12 can be written as 2 root 3, and you should remember that from all of your work with simplifying surds, because 12 is 4 times 3. Take the square root of 4, it comes out the front as a 2. let's have a look at this last one. 1 minus root 3 over root 3. Rationalise the denominator by multiplying by 1. And in this case, I'm going to make my 1 in the form of root 3 over root 3. So I have root 3 has to get multiplied by all of this. So I'm just going to write it out longhand so that I don't make any mistakes. Root 3 by root 3 is 3. Now let's expand the brackets. Root 3 by 1 is root 3. Root 3 by minus root 3 is minus 3 all over 3. Now, even though it looks like we actually can't go any further here. I cannot go cancelling just that and that out, because that, if I've got 3 here, it has to also divide into that one. So I can't just go cancelling anything out. That is as far as I can go finished. And that's rationalising the denominator.